It's Professor Dave. Let's discuss angles.
He knows a lot about all kinds of stuff. Professor Dave explains.
Now we know what lines are, so let's draw a few. Here are two lines, and they cross at this point. But in what way do they cross? Do they approach one another slowly and then diverge slowly, or is it more rapid? In asking this question, we are asking about the angle between the lines. If a door is closed, it's just closed. But if it's open, how open is it? Is it slightly ajar? Is it wide open? The angle between the door and the wall simply represents a way of reporting how open the door is without having to make any reference to any spatial dimensions. Angles are measurements that are independent of the dimensions of objects, and they are ubiquitous in our everyday life. To begin examining angles, we can just look at two rays that start at the same point, which we can call the vertex, and the distance between the rays, denoted by this curved line segment, is an angle. Moving these rays closer together and further apart, while their endpoints are anchored together, will generate different angles. While there are a few ways to measure angles, we will first learn how to use degrees. There are 360 degrees in a circle, so we can take this tiny angle, watch it increase up to 90 degrees, and then continue all the way until 180, at which point we just have a line. If we continue in this direction, it will then go down from 180 all the way back to 0, since the angle will be getting smaller, just on the other side. Let's learn about some types of angles. If an angle is less than 90 degrees, it's called an acute angle. We can remember this because an acute angle is cute and tiny. If an angle is exactly 90 degrees, this is a right angle, and this will be denoted by a square. If the angle is between 90 and 180 degrees, this is called an obtuse angle. So we should now be able to look at any angle and label it as acute, right, or obtuse. Now instead of two rays, let's use two lines. If these lines cross, we generate four angles. What are the relationships of these angles? First, we can examine the angles that are directly opposite one another, like these two. These are called vertical angles, and they are always equal to one another. This seems intuitive by looking at the diagram, but geometry is all about rigorously proving things that might seem obvious, though we don't know why. We also have adjacent angles, which are the ones that are next to each other. And if these are the result of two lines crossing like this, these are also called supplementary. We can also have complementary angles, which add up to 90 degrees. With these rules alone, we should be able to look at a diagram like this with some unknown angles and solve for the unknown angles on the basis of these rules. Let's also recall some relationships between lines. If two lines within a plane intersect at a right angle, they are called perpendicular lines. If two lines within a plane do not intersect, they are called parallel lines. If we draw two parallel lines and then a third line that crosses both of them, we can define some more terms. These four angles on the inside are called interior angles. These four angles on the outside are called exterior angles. Because of the relationships between vertical angles and supplemental angles, we can see that there are two sets of four equivalent angles here. First, each angle is equal to the one across from it. Then, these angles here are called alternate interior angles, and if these lines are parallel, they must be equal. The same goes for these alternate exterior angles. They must also be equal. This is stated by the alternate interior angles theorem and the alternate exterior angles theorem. There is also the same side interior angles theorem, which tells us that interior angles on the same side of the transversal are supplementary. That makes sense because these are supplementary and this one is equal to this one. So these two must also add up to 180. Lastly, angles in the same position with respect to one another are called corresponding angles. We will see diagrams like this quite a lot in geometry, and we may even have to do algebra with them. Like if we set these complementary angles equal to 3x and x plus 10. How do we find the measure of these angles? We just use the definition of complementary angles. They must add up to 90 degrees, so we make an equation, combine like terms to get 4x plus 10 equals 90, subtract 10, and divide by 4, which gives us 20 degrees for x. Plugging in 20, that makes the angles 30 and 60 degrees. Now that we've worked a bit with lines, it's time to look at shapes, which each have some number of line segments for sides. If we are talking about straight lines, we can't have a shape with one line segment, nor two. So it would seem that 3 line segments are the minimum required to produce a shape. And this simplest shape is called a triangle. Let's move forward and learn about all different kinds of triangles. But first, let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.